Okie dokie, let's take a look at another loop method. So we've been working with while loops. This is going to be an example with for loops. So before you get started, set up your scanner because we'll be using some user input in this program. Okay, so now here's the basic structure of a for loop. So we have a for statement, and there are going to be three components in here that are going to be necessary to get the loop running. So the first thing that we're going to do is int I gets the value 1. So this part, int I gets the value 1, sets the initial value. It also creates the variable. So putting integer here actually creates the variable in the for line. We're going to see an example later where you don't need this int, but that's pretty common. Now the next part, not int, we're going to do this while I is less than or equal to 10. So the second part, I is less than or equal to 10. This is the what I call the loop condition. So this is kind of like, imagine a while, a do while loop. So typically, a lot of these for loops run once at least, but this is the condition for which it is going to loop. So say it's going through, I is 3, so it gets to the end of the loop, and then what it does is, 3 is less than or equal to 10, so it loops. So while this is true, it is going to loop. And then the last thing that we're going to have is what's called the growth term. So I++ is the growth term. So how much does the variable grow? And also for this one, I'll specify here that this first one, we typically only want to use this as a counter. I mean, you can create something that acts kind of like a do while, but it's typically not recommended. So anyway, set the initial value, the loop condition, and the growth term. And now all we'll do here is we'll system.out.println the value of I, and we'll see what it does. So we'll run this. And what we get are the numbers from 1 to 10. So what's happening here is I gets the value 1, it prints a 1, and then it goes back up to the top, and then it adds 1 to the value, and then it checks to see if they're true. So this is a little bit messed up that it technically activates this before it checks this, but that's going to be how it's going to work, and then it keeps going. Now imagine we could do a different growth term here. You don't have to just do I++, and we're going to take a look at that in the next scenario. So we'll take a look at another for loop. So for int I equals 0 this time, while I is less than 20. So a little bit of a different statement there. And we'll keep going, and I plus equals 3. So commonly we use assignment operators here when it's anything other than an I++, just to keep it short and to the point. So now, before you run this program, I want you to try to predict what the output is going to be. And then run it just to check what that looks like. So let's see what we get. So the first sequence is going to go 1 to 10, and then we're going to get the second one underneath. So we get 0, which is the initial value, and then it's going to count up by 3. And then the last one that we get is 18, because I will go through with the value of 18, and then it'll return to the top. I will grow by 3, becoming 21. It's no longer less than 20, so it does not repeat the loop. So technically the last value of I is 21, but that's what breaks out of the loop. Now you can also go in reverse order. So for int I equals 10, while I is greater than 0, and you can go I minus minus. And I'll repeat this here, run. And this is our example where it counts down from 10 to 1. Now the last thing here is, we'll take a look at this with calculation of dimensions. So we'll put a couple variables here. So int dimension, int volume gets the value 0. So we're going to use this as our accumulator. So how can we write a loop that will receive the 3 dimensions of a rectangle and then calculate the volume? So for int I gets the value 1. Now how many dimensions are there? There's 3. So while I is less than or equal to 3, then we'll go I plus plus. So here's our prompt. System.out.print enter dimension. Now this is a good one. We can get it to count which dimension they're entering. So this is I, and we'll put a colon there. And then we'll prompt for the dimension. So dimension, it's going to get the value of input dot next int. And then we're going to multiply on the dimension. So volume multiply equals dimension. And then at the end, we'll do system.out.println the volume. The volume is, and then we'll add on the volume here at the end. Don't forget to input.close. Okay, so now taking a look at this, the volume is going to be calculated like this, but there's a little bit of an error in here. So enter dimension 1, go through 4, 4, and 4. You'll see that that yields the answer 0, which is not correct. So that's going to be a bit of a problem. Now, what actually caused that? So this is one of my favorite errors to make because it's pretty common. When you're doing a when you're doing an accumulator that will be multiplying up instead of adding up, you can't start it at 0. So think about my dimensions of 4, 4, and 4. Well, the first time we go through the loop, it does 0 times 4. The answer is 0. Then it does 0 times 4, and you can see where this is going. So when you're doing a multiplying accumulator, you always want to initialize it as 1. So now we can go 1 times 4 times 4 times 4. So if I run this again, so that's, I'll go 4 and 4 and 4, and then we get that our volume at the end is 64. So for loops are very easy to read, but some people do have a very difficult time with understanding the 3 components of this, and visually sometimes for loops can look confusing. But if you get a lot of practice with this, they're very easy to create, and they're also very easy to read and understand. So for loops are a really good tool, alternate to a while loop when you are looping code.